This video is on geometry vocabulary. We have a vocabulary word, we have the definition, and we're going to be putting the example and the important information. Not all words will have an example with it, and not all words will have important information that goes along with it. The first word is a postulate. A postulate is an accepted statement of fact. This could also be written as an obvious fact. This is an obvious fact. It's something that you know has to be true, that you don't actually have to prove that it is, but it already is true. The second word is a theorem. A theorem is a conjecture that is proven. This is the opposite of a postulate. You can use postulates to prove a theorem. A theorem is something that needs to be proven because you cannot just assume it is right. You have to actually prove that this works. Another word that you might hear with postulate would be an axiom, A-X-I-U-M, A-X-I-O-M. An axiom. An axiom or postulate are accepted statements of fact, and a theorem can be proven using axioms, postulates, definitions, anything that is already true. Properties can be used to prove theorems. The next word is a point. A point is a location. It has neither shape nor size. Now, an example of a point, this is actually how it will look. It has a point beside it, a little dot, and you use a capital letter to name it. This is called point A. Point A. Some important information about points is that two lines can intersect at a point. It says can intersect, not that they will, but they can. Lines can also intersect on top of each other. They can also never intersect. But two lines will intersect at a point. Now, what a line is, the definition of a line is a series of points that extend in two opposite directions without end. So for an example, if you have, it's a series of points, so you can have multiple points. If I have 1, 2, 3 points, if I want to name them, I could use the letters A, B, and C. Again, these points are named with capital letters. And a line is that series of points that extend in two opposite directions without end. That means that it connects these points and it keeps extending in both directions, in opposite directions. That's why we have arrows on them. Now we can name these lines. As line AB. We use two letters to name a line. Any 2 points that are on this line can be used to name it. So we have two letters A and B, and we put the symbol for the line on top of it. The reason we do the symbol is because multiple things in geometry vocabulary can be used with 2 letters. So we have to know that this is part of the line. Another one you can also name it line BA. It doesn't matter which direction you name this one. You can name it line BA. We pronounce it line BA because this is part of a line. You can also name any 2 coordinates on here. We don't use all 3. Use any 2 coordinates. So I can also say line AC. That will include B in it, but I don't have to use that letter B. So I can say line AC. You use 2 letters to name that line. Now, some important information about lines is that two planes, which we'll talk about in a second, can intersect at a line. 2 planes can intersect at a line. Again, it doesn't mean that they will. We could have parallel planes so that they don't intersect. or they could intersect at a line. The next word is a plane. This is not an airplane. A plane is a flat, two-dimensional surface that extends infinitely far. The way you name a plane, you name it named using three non-collinear, which I will explain in just a moment, points. A plane is, if you can draw a triangle between 3 points, you have created a plane. You can name the plane using these 3 points. These 3 points up here are still also on a plane. I can't name the plane with these because non-collinear means not on the same line. And again, I will explain that when we get to this definition. So it's a flat surface. A plane is a flat surface, like the piece of paper, that can extend infinitely far. That it actually does extend infinitely far. That means it never stops. So this is an example of a plane. The floor is an example of a plane. The wall is an example of a plane. Anything that is a flat, two-dimensional surface. So a box is not a plane because that's three-dimensional. A point, a single point, is not a plane. A single line is not a plane because that's only one dimension. The next word is collinear. Collinear are points that lie on the same line. So these are collinear points up here. Points that lie on the same line. All 3 of these points are on the same line. Now some important information about collinear is that any 2 points are collinear. Because no matter what, you can draw a line between any 2 points no matter where they are. So any 2 points have to be collinear, because you can draw a line between them. Now non-collinear, again, is points that do not lie on the same line. So these 3 points that I drew right here, I can draw a line between these 2, I can draw a line between these 2, I can draw a line between these 2, but I cannot draw a single line through all 3 of these points. Because what happens is it has to turn, so it then creates angles. So these are non-collinear, which is why we can name a plane using 3 non-collinear points, because this creates the shape of a triangle. So non-collinear points that do not lie on the same line. Coplanar are points that lie on the same plane. So if they lie on the same plane, that means that they are coplanar. But because they lie on the same plane does not mean you can name the plane with those 3 points. You do name a plane with 3 points, but they have to be non-collinear. These 3 points right here are technically coplanar because they are all drawn on the paper. So they're all on the same plane. However, I cannot name this paper plane ABC because this is a line. If I had points on here, on these 3, I could name the paper these 3 points, plane these 3 points, because these are non-collinear points. So points that points that lie on the same plane are coplanar. And we can say that any 3 points, no matter what, are coplanar. However, you cannot name the plane with any 3 points. You must name a plane with 3 non-collinear points. The next word is a segment. A segment is a part of a line that consists of 2 endpoints and all points between them. So it's part of a line. So if we look back up here, we have our line, but we're going to have 2 endpoints instead of 2 arrows. So it's going to be a section of the line. We use 2 letters to name it, just like we did the line, But instead of the line symbol on top, we're going to use a segment symbol, which is why we have to be careful about using the correct symbol. So for segment, if we have the line, let's go A, B, C. We have multiple line segments. Now, between A and B, there are an infinite amount of points, but I'm just not going to draw them. So this is line segment. This is a part of a line segment AB. So I would say line segment AB. I could also name it this exact same one as line segment BA, because I'm going from A to B, which includes from B to A. I can also name another line segment from B to C. And I can name it from C to B as well. Notice I did not put arrows on the top here because this is not a line, this is a segment. Now to incorporate the entire segment, instead of using A, B, and C, I would use line segment, so I would use the points A all the way to C, which will include all of these points. So I can say that this entire line segment is line segment AC or line segment CA. This is why it's really important that we make sure that we have the correct symbols. The next word is array. Array is also part of a line consisting of only one endpoint and all the points on one side of the endpoint. So we're basically going to take a line and a segment and kind of combine the two. So we're going to take one of these points and it'll be our endpoint. So if I want to take point B and go to the right, that means I actually completely cover up this section. So array is a part of a line consisting of just one endpoint. So if I create array here, one endpoint, I have another point, but I have an arrow on one side and it goes in all on one direction. Now array could go in any direction I want it to. I'm just showing for this one as right now. Let's use the letters O and P. Now when we name this array, we have to be very careful on how we name it. On segments and lines, it didn't matter which one we really started with, but on arrays, it is incredibly important. You have to make sure you start with the endpoint, because that tells us where it starts. So if I was going to name this, I would name this ray OP, and how I would draw the symbol is I have my ray starting with the endpoint on the O and continuing to the P. You will not draw PO with the symbol going left. You will always draw it with the endpoint first, so always name your endpoint first, whatever it is, and then have your ray going to the right. So do not do PO with your ray going that way. That is wrong. So we don't want PO. And we also don't want it to look like this. We also don't want it to look like that. This is not incorrect, but you want to make sure you know what your endpoint is, because when you say ray PO like this, it doesn't make any sense at all, because it's not ray PO. It's called ray OP. And we put that symbol on there, and that's how we name it. We have to use the word ray OP. Just like we have to use line segment AB, line segment BA. Just like we have to use line AB and point A. We have to use the words that represent them. Now, opposite rays are two collinear rays. So it's going to be two rays. Collinear means that they are actually they're on the same line, sharing a common endpoint and pointing in opposite directions, which if we go back to a line, two opposite directions without end. So we have two rays. If we have B is in the middle, We have it going to the right going to C, and we have it going to the left going to A. This is considered opposite rays. So if I draw an example out here, instead of using A, B, and C, I'll just use X, Y, and Z. So if I have two rays, I'm going to draw a ray. I'm going to have the endpoint of Y. I'm going to say that I'm going to go to the right. I'm going to go through point Z. To make an opposite ray, I have to go in the opposite direction. My Y is my endpoint. My two opposite rays have to share a common endpoint, so they have to share Y, and I have to go in an opposite direction. So I need to go to the left, and it has to go through another point, so I'm going to use the letter X. And these are actually opposite rays. So I have the fact that ray YZ and ray YX. See how I named Y to Z and then Y to X. We start with our endpoint first. These are opposite rays. Now, an important information that we could put on here is that opposite rays always form a line because they're going in opposite directions and they share an endpoint. So opposite directions will make them form a line.